Well, good morning, everybody. It looks like we're going to be talking about the REXX parsing today. Hopefully everybody can hear me okay. And in the bottom right-hand corner, you'll notice that there's a chat window as well as a questions. I will try to pay attention to that so that if anybody has any questions, we can make sure that we get those answered, as the presentation goes along. You can see from this slide here that if you visit the Themis site, you can get the slides for today's presentation as well as other webinars that have been put on in the past. Let me introduce myself briefly. My name is Gerhard Adam. I've been a ZOS systems programmer for about 44 years now. And so as a result, what we want to do is that in talking about this, we want to kind of give you a sense of what the REXX parsing keyword does, how it works, and I'm basically assuming that most of you have had some exposure to REXX so that, we can kind of get a sense of, the kind of things that we can do with the parsing, as well as some of the reasons for using parsing versus some of the other mechanisms that are available to us. So basically, as we go through this, there are several forms of parsing that are going to occur. Basically, what the objective is here is that what we're trying to do is that we're trying to get a stream of data and assign it into a set of variables. And so there's going to be various sources for this information. You can see the forms here of arguments, for example, that might be passed to a program or a subroutine. The idea of the external, which is basically coming from your standard input or the keyboard. Numeric settings, for example, that we can use to determine what our current numeric values are, reading from the data stack, using the source, which provides information about the particular REXX that we are running, and information about how the program was invoked, for example, and the value, which allows us to work off of literal values, and then the variable or the var form of it, which allows us to parse out variables. So you can see that from the various forms that we have here, that what we're dealing with is that we're dealing with a variety of different sources of information that we can then use in order to be able to assign that data to various values, to variables. Now, a couple of these, like for example, the source and the version and the numeric, are not really operating off of any unique source. In other words, it's not data that we would normally be processing, but rather it's an extraction of existing information. So the results of the parse in the numeric, in the source, and in the version will always be a constant set of values that we can extract. Now, they may be slightly different depending on the implementation of REXX or where you are running the REXX in terms of a system like Windows or under Unix or under TSO. But in general, the point is that these are going to be fixed values that get returned to you as a result of those parses. So the first thing that we want to understand is basically what some of the rules are regarding parsing itself. And parsing is going to occur from the data string from left to right. And so as we process the information, what we're going to do is we're going to go through the string of data, and then based on the template that we have defined for the parsing, we're going to assign that data then to variables. Now, in the simplest form of parsing, the data is space delimited. So in other words, what we're going to have is that we're going to have a bit of data, then we have a space, then we have another bit of data and a space. And that's going to be the simplest form of parsing, where the space separates the data that we are going to assign into variables. And so we have to consider, for example, if we have more data than we have variables, then what's going to happen is that each piece of data that is separated by spaces will be assigned to a variable, and then all of the remaining data will be assigned to the last variable that we have defined in the parsing template. If we have more variables than we have actual data, then any extra variables will simply be assigned a null value. So they will no longer be uninitialized variables, but instead will be set to a value of null that we can then later check if we want to find out what is going on with those. We can also use a period as a placeholder in the definition of variables, so that if there's a particular piece of data that we don't want to collect or we don't want to assign it to a variable, then we can simply put a period in that position, and that data then will be essentially thrown away as far as the parsing operation itself is concerned. Very often you'll put a period at the end of a string so that if you have extra data, for example, that you're not particularly interested in, then that data can be discarded. So what it does is that it creates an environment where we can now use the parse in order to be able to take the amount of data that we have. We can restrict how much data we're willing to process. So if somebody does enter extra values that we're not interested in, we can deal with that. If we have extra data, for example, that is coming in from either the data stack or from a file or from a keyboard, then again, we can use the placeholder as a mechanism for discarding those elements that we're not interested in. Now, obviously, in a situation like that, you do have to be aware of what your data format looks like so that you don't end up throwing away something that you really want. And as a result, very often what may happen is that you may read a particular piece of data in, you may deal with that data in its full form, maybe assign it to a variable when you first read it in, and then from there be able to parse down and make a determination based on how many entries you have or the kinds of things that you're expecting in order to be able to assign the variables from there. Now, one of the things that comes into play here, of course, is that when we are parsing information like this, there are going to be several forms, as we said, of the parse keyword. But in general, it's going to behave the same, when we take a look at the various permutations that we run into. So in this particular case, for example, we have a parse, and we're parsing a variable. So that means that at some point we've assigned some data into a variable, and this could be a whole string of data. It could just be an individual, item, but we want to parse that particular variable. And so we can have an optional parameter in there, and you'll see this in several of them, where we can specify that we want it to be automatically translated into uppercase. So if we code the upper parameter, then that means that we're going to automatically translate the data in our variables into uppercase. In the case of the parse var, we also have to specify an origin. In other words, what is the variable that we are parsing? And then we have the template that we are going to use in order to determine how that data should be divided up into the variables. So a couple of examples then in terms of how parsing is going to work. So in this case here, as we said, everything is space delimited. So that means that the data is going to be regarded as a unique piece of data when it's separated by spaces. So in this case, we have a variable called origin data, and it contains a literal string. This is the original data, and we want to be able to parse that out so that we can see how the data is going to be assigned to the variables that we have defined in our template. So in this case, we have a parse var. Origin data is where the source of our data is, and we have var1, var2, and var3 as the three variables that we want to use to hold that data. So you can see in this case here, the first piece of data that goes into var1 is the word this, separated by spaces. Is goes into the second variable, and then the remaining data goes into the last variable, because in this case we have more data than we have variables, so anything that extra gets assigned to the last variable. In this particular example, we're using the periods here as placeholders. So as placeholders then, that means that the data that takes that particular position will simply be discarded. So in this case, we have var1, again, space delimited, so it's going to have the word this, and then the word is going to be discarded, the word the is going to be discarded, and then the remaining data goes into var3. So again, in this case here, you can see that we basically have 4 positions accounted for in our template. We have 5 pieces of data, so as a result, we collect the first word, and then we take the remaining words and assign them to var3. The middle 2 are discarded because they're represented by the placeholder period in this case. In this particular example, you can see we're using the placeholder now at the end of the template, and as a result, we're going to discard any excess data that we have from var 1, 2, and 3. So in this case, we're simply pulling in the first 3 pieces of data, the word this, is, and the, and then any additional data that is left over will be simply discarded because the placeholder there is going to collect the remaining data that's available. And as a result, we just throw away anything extra beyond the 3 that we wanted to collect. So these are going to be some very straightforward ways in which we can parse information. So anytime we have a delimiter like this, with the natural delimiter of spaces, then the words that we accumulate in our variables are going to be separated on a very simple basis like this. And this is pretty straightforward. There's not a lot that you need to manipulate or to be able to really understand in order to be able to use the data in this particular form. Now, clearly, a lot of the data that we are dealing with is not necessarily going to be quite that well organized or that structured. There's going to be other data potentially that's in there. There may be other things that we're trying to find in order to be able to locate a particular piece of information. And as a result, needing something beyond just space delimiting are some of the other elements that are associated with the parsing capability. So, for example, in this instance now, what we're doing is that we're changing the rules of the delimiters. Now, as we said, the space is the normal default delimiter. However, once we use something like this, in this case, a literal, and the literal is the word the, we've changed the rules. So now the word the becomes the delimiter that we're interested in. And so we're basically indicating here that anything that occurs before the word the is going to be placed into var1. Now, after that, it's still space delimited. So in this case here, var3 would only contain the word original, and then the placeholder would take the extra piece of data that we have. So the use of the literal in this case here changes the rules of the preliminary parsing that takes place. And as I said, once you get done with that, then normal space delimited parsing would occur. Now we could use multiple literals if we wanted to, and we can control exactly how the parsing is going to occur on that basis if we wanted to get really creative about it. Or if we had explicit knowledge about how the data was formatted, we could use that to our advantage so that we don't have to collect half a dozen variables that we're not interested in. Instead, we can immediately use something like a literal string in order to be able to get directly to what we're interested in and then be able to extract that particular piece of data. So as we said, in this particular case here then, the word the serves as the beginning delimiter, with var1 then taking on the words this is. Now, another caution here though is that once we've changed the delimiter to be something other than spaces, then spaces is going to be considered part of the data. As a result, what you have in this case here then is that var1 doesn't just contain the words this is, but it contains the words this is followed by a space. And so if you're extracting information in this fashion, you always have to be aware of the fact that you could have leading or trailing blanks on the data that you've extracted. All right, and once that happens, then that's going to affect other logic in your program potentially, where you may have to deal with the idea of being able to compare this to some other value that you have. So in this particular example here, what we have now is that we have an instance of where we're going to use the literal delimiter as a vehicle for extracting this particular piece of information. In this case, what we want is we want to extract the data set name and we want to extract the member name from this string. Now, bear in mind, the double quotes here represent the literal. The definition in REXX that this is a literal. So the single quote marks that are in here are part of the data. And as a result, we can use those then as a literal that we want to parse on. So in this particular case, we code up the parse var. Our origin is our data set name. And the very first thing we do is that we use the single quote mark as the literal that we want to use as a delimiter. And so effectively what we're saying is that from the first single quote mark to the left parentheses, anything in between that is going to be assigned to this variable called DSN. And you can see from the way this literal is constructed that from that first single quote mark to the left parentheses, we're going to extract the sys1.proclib as our data. And since the left parenthesis is a delimiter, then when we code the right parenthesis as another delimiter, then the word jes2 is going to be assigned to the variable we have marked here as member. So when we get done with this particular operation, we have DSN is equal to sys1.proclib and member is equal to jes2. So notice that in this case here, what we're interested in is that we just want to extract the data set name and the member name, and we're basically modifying the delimiters that are going to be used in order to extract that information. And this is one way in which we can get data extracted. Now notice that there would be no way to do something like this, you know, if you were depending on being space delimiter. As we said, the idea here is that we can use this then as a mechanism in order to be able to just deal with extracting the information that we need in terms of our data set name in this case, or the member name. Very often you'll find things like this done in automation where you may have a system message, for example, where you're interested in extracting a particular piece of data, then you can use that literal as the delimiter in order to be able to locate the data itself. Now, in this case here, we're simply using individual characters like the single quote mark or the left parenthesis or the right parenthesis. But bear in mind, we could use a much larger literal string as well as a delimiter. So for example, I could have used the word proclib itself as a delimiter. And so as a result, the idea is that what we can do is that we can use anything that would represent a value that we're interested in. Okay? Now the question that came in is that with the parse coded as is, what would be the result if the data set was not always in single quotes? Well, in this particular case here is that if we didn't have the single quotes, then what we would do is that we would use the left parenthesis, for example, as a delimiter, and then the data that occurs before the left parenthesis would go into that variable called DSN. So the single quotes really just kind of help illustrate it a little bit easier, but they're not actually necessary. So as I said, I could use the left parenthesis and I would extract the word sys1.proclib into DSN, and then the right parenthesis to extract jes2. Now, in any form of data like this, of course, you do have to be cognizant about what the values are that are in your data. Otherwise, of course, you miss the possibility of extracting, a particular variable or a particular piece of data. So you do have to have some knowledge of what the form of that data is going to look like in order to be able to use a template like this, where you're dependent on literal values. But as I said, very often this is the kind of thing of where we know what the data is, but what we're interested in is extracting a particular piece of that data. And so as a result, being able to use the literal like this can orient us directly to what it is that we're interested in extracting. All right. Now, again, the idea here of using the parse var is mostly just to be able to illustrate the way some of the parsing can occur. And of course, we can do the same thing with the other forms of parsing as well. So you'll notice in the case of the parse external, we also have the optional upper that we can specify to translate into uppercase. And you'll also notice that there is another option here, the line in, which would be used if we were operating under the Unix or a Windows type of environment. So the parse external is intended to retrieve information from our standard input, which represents our keyboard. So in this particular case here, then, the parse external is what we would use under TSO or VM, and that would be looking for information then coming from the keyboard itself. And of course, whatever we enter is going to be subject to the same template considerations with respect to how we parse this out. We can also use the parse pull in order to be able to read information from the REXX data stack, the external data queue. So in this particular case, what we would do is that we can also translate into uppercase. And in this case, any data that we have accumulated into the data stack would be read from the data stack and also assigned to the variables that are defined within the template. Now, the one difference here is that when the data stack itself is empty, then the parse pull reverts to looking for the keyboard for input. So the parse pull is sometimes used to read information from the keyboard when it's known that the stack is empty. But generally speaking, you would want to use the parse external to read from the keyboard and the parse pull to read from the data stack, given that one restriction, which is that when the stack is empty, if you issue a parse pull, it becomes a parse external as far as the operation itself is concerned. Now, in any situation like this, of course, the idea here is that when we are assigning the data to the templates, then the objective is to be able to take the information, assign it to the variables, and then we can perform operations on the variables however we see fit at that particular point. So these different forms of the parse in the first three instances are just simply dealing with three different data sources. Where we're basically saying that, we have data that we've assigned to a variable already, we have data that we have entering in through a keyboard, and we have data that we are processing coming from the data stack itself. Now, the parse value has a slightly different form. And in this case, you'll notice that there's the additional word in here with, which allows us to identify the expression and then the template that we want to use for being able to assign variables. Now, what makes this difference is that this is very often confused with parsing a variable. But it's important to recognize that what we are really evaluating here is a literal expression. So you'll notice by doing a parse value, the time function is going to be resolved, which means that the value that we are actually parsing is the returned time value from the time function. So as a result, when we get that value back, then we're going to parse that value. And in this case, based on the delimiters of being the colon, we're going to separate out the hours, minutes, and seconds. This is probably one of the more common uses of the parse value, where we have something like a time, or we would have some other function that is interpreted returning data to us. So it would represent a literal string that we are parsing out. So anytime we want to extract data from a literal like that, then we would be using the value form of the parse keyword itself. Now, obviously, if you've coded a literal, then you're not going to be using that in a parse, because if you code that, you've assigned it to a variable, so that would be a parse var type of function. So in this particular case here, when we deal with a parse value, we are actually looking at literal data in the parse command itself in order to be able to separate it out. So this is normally going to be something that is resolved at execution time and then assigned to other variables. The parse argument is another form that we can use, and in this case what we're doing is that we are parsing data that has been passed to us, either as a called program or in a subroutine. Now the parse argument gets a little bit more confusing in some cases because of the fact that, you know, people tend to code it up like the parse var or the parse external, and they overlook the fact that we have two designations here in the parse argument. First of all, arguments are separated by commas, and that has to be specified. If you don't, what you're doing is that you're parsing only one of the arguments. All right, so basically in this case here, what we would have is that if we have two arguments being passed to this subroutine or this program, then we would separate those arguments by commas, and that designates the particular argument that we are looking at. Now, part of the reason for this is because of the fact that the argument itself could consist of multiple values. And so it isn't quite as simple as parsing the data that we would normally get out of a variable or from the external. So let's take a look at a couple of examples here. In this case here, you'll notice that we are passing three arguments. All right, we have var1, var2, and var3. However, you'll notice that var1 itself has three specific values in it. So what we are passing then is that we're passing three arguments that actually have 5 pieces of data. So you'll notice that if you look at the subroutine that's being called here, the parse argument in this case is showing arg1, arg2, and arg3 with no commas. And as a result, what we're doing is that the very first 3 arguments are nothing more than a normal parse against var1. In other words, the first guy that was passed to us. Then we separate them with commas, and that is going to give us then the value that was passed as argument 4 and as argument 5. So what's important to remember here is that when we use spaces, we are only parsing the first argument that has been passed to us, or whatever argument we used as far as where the spaces are designated. Once we use the commas, then we are actually including the argument itself. So as we said, in this particular case here, what we have is that we have 3 values that are associated with argument 1, and then we have the second 2 pieces of data coming in from var2 and var3 as passed arguments. Again, in this case right here, using this form, we can go back to the other type of data that we're looking at, and you'll notice that var1 is the first argument, and you'll notice that we use the parsing exactly as we did when we parsed our variable. All right, so in other words, when we did the parse var earlier on that this is the original data, we parsed it exactly the same way, so that arg1 contains the words this is. We have a literal for the word the, that's going to be our delimiter. Then we have arg2 and arg3, which then represents the words original and the word data. And then we introduce the comma, which now parses the additional arguments that have been passed to us. So you'll notice that there are two levels to the parse argument keyword, where we are parsing the data that has been sent through a particular argument, and then a comma to designate a switch in arguments themselves. All right, so this is something that you definitely want to pay attention to when you are passing any arguments. Because very often, as I said, what people get confused about is whether to use the commas or not. And so if you keep in mind that when you are passing the arguments, like on the call statement here, you'll notice we code them up as var1, comma, var2, comma, var3. That's the same way we would express them when we are parsing those arguments later. And if we want to parse data that is within one of the arguments, then we can use our normal parsing template in order to be able to parse the details of a particular argument. All right. Now, you'll notice that we have a couple of others here that we've mentioned, the parse numeric, for example, and the parse version. In this case, what we're doing is that we are getting a predefined set of values returned to us. Then we can assign them, of course, to variables if we like. But generally speaking, this is something that you would use if you wanted to check a particular setting or if you wanted to check a particular value. Like in the case of the numeric, we can determine what our default numeric digits is set at. We can determine what our fuzziness is and the type of notation. In the case of the parse version, we're going to get returned to us the particular REXX version that we are running. And so we can use that information in order to be able to make a decision or to just basically assess whatever the current setting is. But notice that we are not working with any kind of variable data. This is going to be a fixed set of values that gets returned to us every time we invoke this. So we're simply extracting information that is already defined within the REXX environment. Now, one of the other things that we can do with parsing is that we can use absolute and relative positioning. So in this particular case, very often what happens, we have data that does not lend itself to all these parsing techniques that we've been talking about. There's no literal, for example, that we can specifically identify. It's not space delimited. There's no particular notation that would indicate how we can locate a particular piece of data. And as a result, we very often have to rely on explicit columns of information. So in other words, we're interested in the starting column and the ending column of where a particular piece of data is. And this is something that is normally done in a lot of programs where you might have a data record, for example, and you're interested in the specific fields of that record. Regardless of what they contain, they're going to have a fixed length, and as a result, parsing does not really lend itself to that if you were using something like spaces. For example, you could imagine a record, for example, that might have an individual's name in it, maybe their address, and you can see that immediately, we would start running into problems based on a particular name, whether it's got, first name and last name, whether there's a middle initial, whether there's a title. Same thing with an address, for example. Street names might consist of one word or two words or other designations. And so as a result, being able to parse that kind of information would normally be dependent on saying that the field begins in this position and goes for X length. That way we don't have to mess around with delimiters. We're simply going to use the column designations there to indicate where we are going. And we can move forward and backwards in a particular notation here. So, for example, if we use an unsigned number when we're parsing, then that is going to relate to the specific column number that we are interested in. So in this case, we do a parse variable of the variable alpha. And you can see that's nothing more than the alphabet shown up here at the top. And so the variable that we want to fill is a variable called C1. So what we do is that we indicate where do we want to move the cursor. In other words, what column do we want to start at? And in this case, column 8, which is the letter H. And then our ending column is column 9, all right? And so we're extracting 1 byte of data. Now, again, a lot of times people get confused about, well, you know, relative positioning and absolute positioning, you know, and how much data are they moving? Well, it's really pretty simple. You go to the column that you want to extract, in this case, column 8, and since I only want to extract 1 byte, then my ending column is 9. All right? In other words, 9 minus 8 is 1 byte. It is that simple. Similarly, the next variable, I start at column 5, go to column 6. All right? Again, 6 minus 5 is 1 byte, so I'm going to extract the letter E in this case. And then again, we can go to column 12 to 13, and then 16 through 17. And when we extract those, then we extract the individual letters here in order to be able to use the say command in this way. All right? And then, of course, one of the other things that we can do is that in this case here, we can use the relative positioning. All right? And relative positioning then says that we are moving relative to the current column. All right, and if you do that, you'll notice that again, if you count the first 13 positions, that will position us to where the letter N begins. And then we want to move 3 bytes. And we're extracting the N, O, and the P in this particular case. So again, if you were to count this out, what you'll notice then is that the plus 13 represents the first 13 characters in the alphabet. And then we're going to extract the next 3 using the plus 3 in order to be able to get that information. Now, again, if you take a look at some of these, this helps when you take a look at some of the examples and how these can be mixed and coded. Because it looks confusing at first, but it really is rather straightforward when you take in mind the columns themselves and you're simply indicating like, how many do I want to skip? You know, what do I want to use? And how long is the particular field? So in this particular case here, you can see that what we're doing is that we are beginning in column 3, all right, which is the number 3. And what we want to do is that we want to extract for 3 bytes, and that's represented by the plus 3. So in this case, we begin at column 3. W1 is going to be the variable for a length of 3. We're moving the cursor 3 positions. And so we extract 3, 4, and 5. Now, what's important to remember here, and this is why we talk about moving the cursor. In this case here, once we've done the plus 3, the cursor is now positioned at the number 6. All right, we started at 3, we moved 3, and now we're positioned at the number 6. So at this point now, the W2 variable is going to be filled with that cursor position right up until the end. All right, so 6, 7, 8, and 9. So the remaining data goes in there. Now you might wonder, well, how do we know what the length is? Well, we know what the length is because the next value is an absolute column number again. And so REXX basically says, all right, from your current cursor position to whatever the next position would be, all right, is not going to be based on a fixed column number because there's no sign there. And so as a result, he says, all right, W2 is going to start from our current cursor position to the end of the string. And then our last string of data, again, is going to begin in column 3. We don't have an ending, and as a result, we just run to the end of the string again. So you can see W1 controls it by 3 characters. W2 does not have an ending. As a result, it runs all the way to the end. W3 begins in column 3, it also does not have an ending value. So it runs out all the way to the end as well. Okay? And so again, in this case here, what we can see is that we can use these different values here in order to be able to designate a specific column and then the length. And notice that we can reuse the column numbers. So in this case, we start at column 1, we extract S1 for a length of 3. We start at column 1 again and extract S2 for a length of 5. And notice that we can also use negative numbers as well as the value 0 to indicate cursor position. So for example, in the first instance, we use the literal to locate the values I, j, k, and then we backed up 3 and then extracted into a variable called found of 3 bytes. And so in this case, we located I, j, k, so that was where we delimited the string, backed up 3, which put us at the F, and then we extracted F, G, and H for 3 bytes. And then, of course, in the second instance, we found I, j, k, but this time we did not move the cursor. We used the +0 and then extracted for 3 bytes, and we extracted the I, j, k itself. So in that instance, not only did we use the literal to find where we were going, but we also used the literal itself as what we wanted to extract. In addition, we can use this as a variable. So we can take the literal that we were searching for and actually set it as a variable itself by simply coding it in parentheses. And so by coding it in parentheses like this, what we have now is that we have this variable ijk, this literal that we want to use as our delimiter, and we are coding it in parentheses, and that is going to now be used in our parse var as the delimiter itself. So in this case, as we said, we have a parse var. We're going to use ijk as what we're locating, and then we do a found +3. So found is going to be assigned for a length of 3, and that's going to represent our ijk. Now, this use of a variable delimiter can come in quite handy if you're dealing with data where the delimiter may change, or you may want to change it and use the same parse statement. Then by being able to assign it as a variable, you can effectively work with data where you know where the delimiter is, but you don't necessarily know what value it's going to be. And so in that particular case, you could use something like this. For example, there's a product that you can use in order to be able to read screen data. And what they do is that they use the vertical bar as a delimiter for all of the columns that they return. But the user has the ability to choose a different delimiter besides the vertical bar. And so if I'm going to be parsing data from that screen, I don't need to know what the delimiter is that the user selected. All I have to do is extract the first byte of data. That will be the delimiter, and then I can use that as a variable, and then I can process the screens regardless of what the user has chosen in that particular product. So that's the kind of situation where you would use something like that. Now, you can also see that in this case here, we can use the plus and the minus to move the cursor to the left or to the right, and we can use the equal sign to indicate an absolute column that we want to use. So again, these are just different ways in which we can designate this. Now notice that in this case here, the idea is that we can use the move C variable in this case to indicate we want to move 3 characters. All right, we want to move the cursor 3 positions. Or we could have placed a minus sign in front of that and said, go ahead and back up 3 positions. But we can also use the equal sign to indicate an absolute value or an absolute column value that we want to use. So we have everything available to us here in order to be able to code up using these particular columns and coding it as a variable as well. And so as an example, let's say we have a file, and in this particular case, the file has a name field that goes from columns 1 through 16. We have an address that goes from columns 17 through 35. We have a city, and then we have a state designation. And basically what the code then would look like is something like this. And you can see from the 4 variables that we have at the top that would represent the records we read from this file, that very often there's nothing we can actually easily parse on. All right. In other words, the name runs right into the address, runs right into the city. And so the only way we can reasonably extract this information is based on column number. And you can also see based on various values that are in here, like for the names, you can see that it's not always easy to indicate, you know, how we would parse something like that out if we were using spaces. So in this particular case here, you can see the different forms of how we can parse this information. We can begin in column 1 through absolute column 17, and that's going to indicate the name. All right, then beginning in column 17, and then you can see we have several different ways in which this has been expressed. We can either go for a length of 19, or we can go explicitly between 17 and 36, or we can use the variables that have been set to indicate we're either moving 19 or we're going to an explicit column 36. These are all different ways of expressing the same thing. And we would get the address out of that, and then we start in column 36 through 49 to get the state and the city. But this would be a way of being able to process a particular file that has designated fields and using the column numbers then as a vehicle for doing that. Now, the one thing that I would mention in this particular case is that very often some of the parsing, you know, you might look at and say, well, you know, I could do this in other techniques. You know, I could use the substring, for example. You know, I could use, you know, other functions or other mechanisms to be able to extract the data. You know, this parsing stuff looks more complicated. But one of the things that's important to remember is that substring, for example, and some of the other built-in functions can be a lot more expensive when it comes to CPU usage. And as a result, one of the real concerns is that if you have a REXX routine that is processing a large volume of data, then that kind of difference starts to become noticeable. And so as a result, you know, while it may not make much difference using a parse versus a substring when you're processing 10 records or 100 records, when you start getting into larger files, this starts to become a very notable difference. The substring, for example, runs about 2.5 times slower than the parse. So as far as CPU usage goes. And so if you're dealing with large amounts of data, and I have customers, for example, that might be processing a file that has 100,000 records or 1 million records in it, then that kind of performance is going to become noticeable. And as a result, using the parse is going to be a much more efficient way of processing and dealing with large volumes of data. So it's just something to keep in mind that, you know, despite the fact that some of this looks a bit more complicated than you might be used to, the fact is that when you take a look at some of the examples and you take a look at having these defined as like for fields within records and things of that sort, then knowing your data allows you to be able to set up a parsing keyword that makes sense for the data that you're processing. And as a result, you can do all of the things that you need to do, both in terms of fixed definitions as well as using variables, being able to be dynamically responsive to a lot of information, as well as a lot of static definitions. So in all of these cases, basically you have almost an unlimited way in which you can take the data, manipulate it into a variety of different forms, and get exactly what you need out of it. So as a result, this is going to be one of the more powerful elements in REXX programming that you can deal with. Does anybody have any questions?
Hey, Gerhard, there were a couple of questions in the box. I can just read them out if you'd like.
Sure, if you would.
Okay, toward the beginning, we said with the variable, back in the sys1.proclib example where you were parsing
right
dataset name, does the actual name sys1.proclib stored, I assume in DS name, is it stored somewhere in REXX? Not sure what that...
You mean, is it kept internally in REXX if we go back to this right here?
Yeah.
Well, the DSN is the variable name in REXX, and as a result, when the sys1.proclib gets stored in that DSN, that variable is part of the REXX program. So yes, in that sense, it's resolved as like any assignment clause would be.
Okay. Another question, does it matter if you use double quotes or single quotes when specifying a delimiter or variable?
No, actually the rule in REXX is that whatever you start with, you must end with to establish it. So in other words, I could have done this example right here, starting it and ending it with a single quote, and then using the double quotes around the sys1 and the right parenthesis. But whatever you start with in a literal is what you must end with. But that's the only way REXX is going to know what the beginning and ending of a literal string is. So you could interchange them, but you do have to pay attention to that.
Okay, and the last question is, will the slides be available? And the answer to that is they are already available at the Themis website. If you go back to the title slide, I think we have the URL on that. themisinc.com/webinars. Both of the slides and the replay of the webinar will be available on the Themis website under the webinars tab. So that's all the questions that have been submitted.
Okay. One other final point. This is not part of the slides, but I'm going to just show this so that people have an idea, because I'd mentioned the performance thing. And, I realize a lot of people may not necessarily be, into performance or understand it real well. But one of the little tricks that you can pull to sometimes get an idea of what something does is to use the TSO time command. And here's an example. The time command would just be coded exactly as you see here. All right. And in this particular case, what I have is I have a loop of 100,000 occurrences where I'm parsing this data, and then I'm doing the same thing using a substring. Right? Just as an example of testing out what the resources that I'm going to use are. And the results of that are going to produce this. This is the result of the TSO time command. And the column to note here is where it says service. And the service in this case here indicates the CPU service units that have been used since the last time that command was issued. And so if you look at this, you can simply subtract the values from each other to find out what they took. So that means that before I did my parse, my service was at 3126. After the parse, it went to 3664. Yeah, ballpark around 500 service units. And then from the 3664, it went to 4833. That's using the substring function. In this case, it went up almost 1,200. So you can see that I used about 500 service units for the parse and about 1,200 service units to do the same thing using a substring command. And this can give you an idea of the performance cost that would be associated with some of these things. So again, I just pointed out for those of you that might be interested in how you might be able to measure, the performance of various routines like this, set up a large number of loops. You can use something like the time command, as a vehicle for assessing how much service you consume. And as a result, you might be able to draw some useful information comparing how these functions work against each other. As I said, in this case here, I used a loop of 100,000 to be able to get a notable difference. If the loop had only been like 10 occurrences, it would have been negligible. So it's a technique that you can use to gain a little more insight into the performance of some of these keywords and functions. All right, so without any further ado, if there's no other questions, then that pretty well wraps it up for anything that I have to say at this point.